hello to Git-driven workflow and Jenkins advanced usage. So this is basically a presentation of the infrastructure used by Linaro continuous integration and how we use Jenkins, how we use Lava, and I try to keep some time at the end to have some questions. If you have some questions in the middle of the session, just feel free to stop and ask. So the first part is about the infrastructure that we have in place. It's pretty standard. There's one VCS server. This is where we store the source code. There's two parts. Part where we pull the source code to do some builds, and where we are going to store the configuration of a build job. So it's just a Git plugin in Jenkins. So any Git server can be used. So we are usually using gitliner.org or any third-party service, kernel.org and GitHub. There's the build part. So we rely on Jenkins. We have one Jenkins master and multiple slaves. The master is hosting all the jobs that we have currently. It has the feature to submit build jobs to Lava. So I guess many of you are already familiar with Lava, the test and validation automation tool that we are using. And we have also multiple slaves. So the slaves are used to run build job. So I'm saying build job, but it can be anything. Obviously, it's pretty flexible. It can be just running tests. Most of the slaves today are bare metal, or I'll talk a bit more about the Docker slave. Docker slave are a new type of slave that we are using today. We used to have EC2 slaves as build slaves, and moving to Docker brings some advantages. I will give a bit more detail about that. And then we have test and validation automation, which is Lava. We have multiple micro instances. The main one is in the Cambridge office, validation.linaro.org, and we have a few others for segment groups like LNG, and we have also some instance for OpenStack testing. So that's basically the big picture. There's also the storage server. So basically, each time we do a build, we publish the jobs, the build artifact into a storage. So we are in the transition to move to Amazon S3 for multiple reasons, technical reasons. There's also the cost. It's cheaper. I'll explain a bit more about how we do that. So on this...
One question.
Yeah.
So you say the build jobs for Lava, when you do your testing, you put it on the master, or is it usually a slave node that would run those jobs?
So what's happening is the master, Jenkins master, is taking care of the build side and scheduling. So it triggers a job, which is running on the slaves. And then the slaves are going to publish the build artifact that they are going to produce. And when the job is done, we have some kind of pipeline where the slave trigger another job on the master side, which is called post-build to Lava. And this job is just submitting Lava job definition to any Lava instance.
Okay, so the slave actually, the slave's the one that's running the Lava test, not the master, or is the master actually?
None of them is running the test.
They're the ones that start the test.
Yeah, they just trigger the test. And Lava is taking care of the remaining steps. So Lava will run the test on the device requested.
But the master actually is the master is not actually spawning that instance of the test, right? Is it a slave node that's spawning it?
It's the master itself.
Is there an advantage to having the master spawning that test?
There's no advantages. Actually, we can do that on the slave side. It's just a design implementation that we have chosen. Technically, there's no reason to.
But then you're checking the status of
the
job, the master.
So post-build Lava is doing a bit more of that. So I can go back in details a bit later. But post-build Lava doesn't only, well, it's going to submit the job, but it doesn't do only that. There's some advanced features which are used into this job. So basically, we can link a Lava job to the build job itself. So basically, on the build job UI, you will get some information where you'll find the Lava job submitted. And also, we have another job which is called check Lava status. And so basically, we update the build job with the results of Lava. So this is why it's running on the master. It's easier to do all this code there.
But then you're regulating running on that master, and you really can't spawn another Lava job, or do you run it on? Do you have different nodes on the? Oh, sorry. Do you have different nodes on the master too that you can run multiple Lava jobs, or is it just regulated to a singleton?
No, it's just the master itself, because the master can have multiple executors. So it's just one executor that is running on the master. So the master is only running low resource jobs. Basically, post-build Lava is just submitting a JSON file. It doesn't take any resources on the master itself.
Does Lava report back to the master?
Lava, no, but we are doing some pooling on Jenkins side. We have a job, so this check Lava status. So basically, we have some kind of a pool of Lava job ID that we have submitted, and from time to time, we are going to check this pool, get back the results of Lava, and update information on Jenkins. And once Lava job is completed, we just clean up the pool. Very simple. Other advantages is that you can do that from command line. You don't have to go through Jenkins UI. Some people are complaining that the UI is very slow, so it's very helpful to do that. So at this point, we have a new build job. So the build job is triggered using commit changes, or it can be triggered manually, depending on your job. It's defined in your job yourself. And then, optionally, you can publish build artifact. Nothing forces you to do that. And same here. You can hook up to Lava to run some tests or not. So some of the things that have been covered in a higher level is that having the configuration of a build job into repositories make it easier to maintain. We have all the setup that we are using maintained with Ansible. So basically, what we have here can be deployed on your local machine. So we can have Jenkins running on your laptop with the Docker slaves, and also all this mechanic. Everything is available. So you can use exactly the same tools that we are using, run Ansible, and deploy that. Everything is described. Sorry. even the plugin that we are using. It can be useful if you want to reproduce our setup. So for example, in this file, you can see that we have a bunch of plugin and the specific version that is used. Yeah, and we have a lot of plugins. So Jenkins can be extended with plugins and API, and we are using them a lot. I'm just mentioning a few plugins that are really important. The matrix-based security plugin. It provides a feature that you can have public jobs as well as restricted jobs, private jobs, on the same Jenkins master. Gary trigger, so you can have triggers based on Gary changes, like for example the tuition working group is doing. The Docker slave plugin, and Groovy. So Jenkins provide a built-in scripting language, and you can use Groovy to access to the API and do some advanced jobs. I'm just going to give an example where we use that. Yeah. So I was talking about check Lava status. This is exactly what we are doing. So in this case, this job is written in Groovy. We use the XML RPC interface of Lava. We get access to the Lava job, and we request the job status, and then we just update the build job, the Jenkins job, with the status coming from Lava. So it's very easy to extend to whatever tooling you have in your build pipeline if you want. The API, Jenkins provides an API, so you can do some data mining, so save metadata in your jobs, for example, and grab this information. It can be used for custom dashboard, QA report made by the QA team is using that. We have new also dashboard, so it can be used also like that. So Open Data Plane is also using the API. So we are running Open Data Plane jobs into ci.linaro.org, and the access to the build job. And as you can see, they have the build status available as part of opendataplane.org. And we have also Coverity. So we are running Coverity on Open Data Plane, so we can also have the results here. I'm talking about our specific feature. It's really specific to us, our setup, and how we are doing things. So for people, especially people working with jobs within Linaro, and if they want to create a new jobs, this is things that they might need to know how to do that. So initially, our team, Built on Baseline, was supposed to take care of that and have a knowledge to create jobs with some specific information that needs to be known, and it was easier to delegate to a specific team to do that. Now we are growing, and we try to enable developers to do CI jobs, build jobs themselves, and try to provide them the most flexibility that we can. And for example, publishing was pretty hard before. So for historical reason, we used SSH Publisher as part of Jenkins plugin. It's a two-step publishing, and it was really difficult to use, simply put. So you need to be familiar with that. We replaced that with Linaro CI. It's command line tool. It's much more easier to publish jobs. So it's a single line that can be used in your job. And it has multiple API available. And one of them that just been added is the ability to publish job on Amazon S3. Obviously,
does Linaro CI publish to snapshots at linaro.org?
Yeah, definitely. We have submission of Lava, Lava being a critical part of our CI loop. We have all this mechanic using post-boot Lava to submit jobs. So all the links are available as part of the slide, so if you can take a look. We support micro instance, so we have now dedicated Lava instances for segment. So it's very easy also to submit to a specific instance of Lava. We have pre-installed in our toolchains. So trying to reduce the build time and also provide multiple toolchain. It might be useful in some use case. I think that I have a link here why it could be interesting. So this is this build job is a build of channel core EDK2, so UEFI, and Leg is interested to build EDK with new toolchain and older toolchain. So in this case, we are supporting GCC 4.8, 4.9, and also CLang. So we pre-install this toolchain. We don't have to reinstall them. They are already available. It reduces the build time, and we can have all these choices available, which is not always the case depending on your operating system used. So most of the distro have one main toolchain at some point. So if you want to have an older toolchain or a newer toolchain, it's not always possible to just use the one coming from the distro.
Daily pre-built toolchain, or?
Yeah, it's pre-built toolchain. This is the pre-built toolchain released by the toolchain working group. They are just extracted. So it's also dogfooding. We reuse them. We are testing them.
Unfortunately, it's still 4.9, but.
Yeah. So I won't comment on that, but I guess 5 is coming very soon.
5 is coming.
On the Linaro specific features, you have also the package builders helper. So we have a set of jobs. Because we are also doing some distribution integration work, we have the need to generate packages. And now we have a system in place to generate Debian packages. So it creates your source package, it creates the build, the binary build, and then it's deployed. So I have this example here where we build open data plane packages. So it's coming from the CI loop from ci.linaro.org. So we see that we are building for JC, Utopic, Vivid. and we are going to extend that to airplane packages as well.
How is that coming along, the RPM support? Started yet?
Yeah, it shouldn't be very hard. So in this case, what is happening on the distro side? So people doing distro are building from a clean CH root, and in this case we just replaced that by a clean Docker slave. So we have Docker images for Ubuntu, Debian, Fedora. We've been requested to include CentOS. So basically you just run your Docker image and run the native tools used by the distro to generate packages. So, things to summarize, I think, for the Git driven. So, all the build job configuration, including also the server deployments, are under Git. The obvious advantage is that we have a history. It allows to roll back the changes if we need, so we can upgrade plugins, change the build job, going back and forth. Again, it wasn't possible before because we have job created through a Jenkins UI, and you don't have the history of the changes on your job. So it was very difficult to do some changes. It's automatically deployed to Jenkins, so it's just a matter of creating your YAML file, commit, and it's deployed. We have better security because we have this review process. It goes through Gerrit. The Git server is running Gitolite, so you can use the ACL. You don't have to provide access to everybody to your Jenkins master. The Jenkins master becomes just a read-only view. And the other advantage is you can do everything from command line, things that has been asked by the kernel working group, actually. On the other advanced features, so yeah, we have the bare metal slaves. So it improves the performance compared to EC2, definitely. We have native ARM machines, x86, so we can do some dog fooding also. And
which boards are you currently using for ARM?
so on ARM, we have most of the machines that we are using actually are IPM Mustang. This is the one that we are using. But there's no limitation in this case. All that we need to hook up a slave is just SSH. So it's registered as a dummy SSH slave on the Jenkins side. So as long as you've got SSH, it will just work. So you can even run on BeagleBone if you want.
Just in Docker inside of it.
Yeah, you can run Ever natively, so bare metal. You can use Docker if you want. And that's what we are doing. We are doing both use cases. Yeah, we've been able to run on BeagleBone and run. One thing is that Jenkins to talk with the master need Java. So you need to have a Java client running, Jenkins clients running on the slave. And then everything is going through SSH.
No Line6 ports in there?
Actually, no. There's no, but that's definitely possible.
Is there a good way to debug jobs given the fact that they are now in Git? So in order to make a debug change to a job, to a YAML file, you have first to commit to Git, get it to a review, then deploy it, rather than going through the web interface. Is there a better way?
Right now, no. This is something that we have in mind. Simply, for example, you want to test a job. Right now, there's no issue to create a test job. I mean, you can just create a job, give all the permission that you need, play with it through Jenkins UI if you want, using Docker Slave. It doesn't cost any resources, and do whatever build, debugging until it works, and then you can just turn it as an official job.
Okay, thank you.
So for like kernel type patches that you would get in, where, I guess the question is from a quality standpoint, you're saying they actually get merged into the tree and then pushed out for general usage, right? From
Yeah.
Garrett. So where in the process do you do your builds against def configs and your sparse builds and mismatch builds and check patch and all that wonderful stuff? Is that in a job, or do you not do that? Or is that all done
It's in
Git
the-
hooks?
It's in the job. Yeah, again, I will come back to you because after that, I'm just going, we are close to questions and we can go in details how a job is and to describe a job. But for example, if you want to run some tests beforehand, like check patch or something like that, it should be done in the job itself in this case. Or you can also delegate, but usually it's done into, when I say delegate, it means that you can have a job, you can have a build pipeline where you have one job to do the build itself, another job to do a set of tests, check patch, maybe submit to a device, specific device that you want to try with the kernel build and so on.
And how is the submitter notified? That is it emailed back to the submitter, or how does the person even know that job failed?
There is an email notification. Again, it's part of the build job description, so we can go through one and see how it works, and maybe a more advanced example.
Have RC bots or something?
Which one?
RC bots or something.
We have a RC bot. Actually, it's used only by the Qualcomm landing team for a job. So basically, they have a notification on RC directly when the job is started, when it fails on their RC channel. But there's multiple options for notification side. Yeah, advantage of Docker slaves. So it has a lot of advantages. One which is pretty interesting is that the builds are reproducible. So you can share the Docker image, run your build script. So someone else, another developer, can reproduce your build failure, for example, because every developer doesn't have exactly the same setup and so on. So using Docker slaves, you have this reproducible build environment. Images can be shared. They are not yet. That's a plan that we want to do. So we don't have registry yet. The plan is to have ARM64 and ARMv7 registry, so people can just use the same images that we are using. Yeah, and it's also more flexible for the end user. So when you compare bare metal machines to Docker slaves, bare metal machines, you have to restrict access to the user, because you can't simply run as a super user on the bare metal machine. You can break the setup, so the slave won't be usable anymore. When you have Docker slave, it's running under an instance, which is we can grant you root. You can install dependencies. If you need more dependencies in your build, you can pull all that stuff very easily. And then, I mean, when if you screw your Docker instance, it's just deleted. You run another one, and so on. So it's much more flexible for the end user. Yeah, with all this API available as part of Jenkins, as part of Lava, and so on, it's very easy to build a pipeline with the integration tools. So you can have a custom dashboard for your specific use case. You can create some tools using Groovy to access metadata and so on. A lot of information that can be used by several people, like your QA team. So let's take a look to a job. So all the jobs start in the same way. You have job name, project type. So you have two types for a project type, freestyle or matrix. Freestyle is just a regular plain build. Matrix, you have parameters where you can go through a matrix. Let's say GCC, and you can have parameters when you say 4.8, 4.9, and so on. Log rotate, it's a classic option that we are using. Properties, this is where you describe access. As you can see, we can provide read access to the job, or we can just limit it. We can also provide build permission or cancel job. For this one, we have a few parameters. Here, we describe which slave we want to use, Docker topic. We are using the Git SM plugin, so we pull the code from EDK2. The triggers, when it's going to be built, it's a polling job. So
one thing that has been a common request is to have the jobs run immediately when the commits happen. So now we have the habit of using polling rather than directly acting on the commits. Is there any plan to change that?
Actually, no. So what is provided to the users is once a job is deployed, they can just go to UI and run the build. That's probably something that we can provide as a third-party tool.
I mean, people want to get the results as soon as they have done the commit. They don't want to do any manual steps to have it like continuous and automatic. Yeah,
but as I said, from a technical point of view, the only way to do that is to provide another tool. So basically, you submit. You are going to merge your job, and you need a tool to trigger that, even manually.
Couldn't you just put a Git hook in that does a lot of this stuff, so when you commit, it would spawn that job? I mean, this should all be able to be automated through Git, right? I mean, if you throw a Git hook in there, you should be able to, unless the developer actually has to know and have to build this YAML file. I mean, it should be able to just throw a quick Git hook in there that just launches it, right?
Yeah, what I'm saying is that you need to define an interface to say, I want to do a build right away. And it should be part of the tooling used.
Well, I guess that would also run into problems if you try to test every commit, if you have a patch series that you want to have pushed. I mean, you have that somehow in the job you have to define it's patch 0 or at 1 through X, right? I mean, you want to build every commit. That could really bog down the Jenkins server too. I mean, if you want to test every commit, because a commit's just more than possibly, patch series, right? So are you going to want to test a series, or do you just want to test the single commits?
As far as I usually see, people don't make big commit series at once.
Yeah, in this case, it really depends of your build job. It's up to you. So you can define an interface and say, I want this range of commit, or you can just have a parameter to say, I want this commit applied. That's what is happening with the Garrett trigger, actually. So basically, you say, the Garrett trigger is going to see a new Garrett patch, and it's going to try to build this patch. So this is just a commit ID which is passed.
Yeah. So just what the toolchain working group, we thought about this a little bit. Two use cases. One is checking out the upstream repository, which you want to do not every single commit, but like every hour or nightly or weekly. And then when you do your development, you want to test each of your commits as a patch series. And that's best done as part of review, and we use Garrett for that, Garrett trigger. So Garrett trigger takes care of testing every single commit, and polling a repo takes care of tracking upstream repos.
Yeah, because Garrett does single commits anyway, not commit series. Makes sense.
Yeah, so back to a few questions that you asked. So basically, at the end we have here, so we describe what is happening for build. So build steps, publishing. Again, everything is under Git, so everything is publicly available. You can have a look. Here we trigger post build to Lava, so we submit the job to Lava. And here we have, at the end, email notification as a publisher. So basically we say, if something happens, well, if it fails, send a mail to this mailing list or to this email. And you can also have a IRC bot to do some notification. Just for information as well, we don't have only YAML file in this repository. We have here some subdirectory where we have a job definition. So for example, for core site testing, we have Lava job definition as part of a repository. So we submit a job to D01 and TC2 platforms. And this is the description of Lava job definition. So for example, when core site is built, this is what we are going to submit to Lava.
This is Lava YAML file, not.
Yeah, this is
not Jenkins YAML.
Yeah, this is not a Lava YAML file. So the new dispatcher for Lava is going to use a YAML file for test definition. Right now it's still JSON file, but you can right now start to write your test definition as YAML. Anything that you would like to cover more in details? Any questions?
So, question about Docker slaves. When you say Docker and generally virtualized slaves, are those only Docker or also LXC, LXD, and are KVM slaves supported?
Actually, it's only Docker because there's a plugin available, and it's pretty versatile. I don't know if there's any LXC plugin, but that's something that we can check.
What would be the use case?
So in this use case, the two-chain working group builds, they have evaluated multiple container technology to do their builds, and they decided to go for LXC instead of Docker, for example. And that's what they want to use. So that's the use case here.
Our main use case is to limit resource usage inside a virtual machine or a container. So I understand Docker can do that. I know for sure LXC can do that. I just know LXC, I don't know Docker yet.
Okay, I think we are at the end of the session. Thank you.